Revision sheet on find the area of the figure on the right. So what we see is two shapes. We see a rectangle and a triangle. Now to start off with the area of the rectangle, area of a rectangle. So area of rectangle is length multiplied by width. The length is going to be 8 and the width is going to be 4. So length multiplied by width, which is going to be 8 multiplied by 4, 8 centimeters multiplied by 4 centimeters, and that gives us 32 centimeters squared. So this here is 32 centimeters squared. Now, for the triangle, what we have is a half base by height. The base is 8 because it's the same length, and the height is 3. So h equals 3 and b equals 8. So the area of a triangle. So area of a triangle is a half base by height, a half bh, b multiplied by h, which is going to be a half multiplied by 3 multiplied by 8. What that's going to get us is going to get us 12 centimeters squared. So 32 plus 12. 32 plus 12 is going to give us 44 centimeters squared. Okay, so 44 total is going to be 44 centimeters squared. Okay. So total area, you get the 32 plus 12, that's going to get us 44 centimeters squared. Okay, next one. So 44 centimeters squared, first answer, we got that correct. B, the volume of the given solid is 1320 centimeters cubed. Find the height h of the solid. So this is a cuboid, so the volume equals length by breadth by height. So length by breadth or width by height. So let's say the length is going to be 20, the width is going to be equal to 12. So we know that the answer here is going to be equal to 1320. So all we got to do here is put in our numbers. 20 multiplied by 12 multiplied by height equals 1320. 12 multiplied by 20 is 2040. So 240 h equals 1320. Okay. Okay, so what we're going to get next is height is it's 240 multiplied by h. So when you bring the 240 over the other side, because it's multiplied by 240, it's going to change it to divide by 240. So 1320 divided by 240, and we're going to get is 5.5 centimeters. The height is going to be 5.5 centimeters. Okay, let's check this out. 5.5 centimeters. We're correct. Okay, next one. Find the volume and the total surface area of the rectangular prism. Alright, so what we got to do for this, if you read the notes at the front, okay, what we know is that the volume of a prism is the area of one of the faces multiplied by the length. Okay, so we need the area multiplied by length. Okay, so we need to find the area, and then we need to multiply by the length. Okay, so length equals 4. And the area is the area of a triangle. Okay, so the triangle of area A is going to have a height of 8 and a base of 6. So area of triangular face, area of triangular face equals a half base by height, which is going to be a half. Base is going to be 6. Height is going to be 8. So half 6 times 8 is going to be 24. 24 centimeters squared. Okay. Now to get the volume, we got to multiply that to length. So volume equals A multiplied by L. And that's going to get us 24 multiplied by 4. And that should give us 96 centimeters cubed. Let's go back one. Back 2, 96 centimeters cubed. Now next part now. Okay, find the total surface area of the triangular prism. Okay, so find the total surface area. Now to find the total surface area, we need to count how many surfaces there actually is. Okay, so we're just going to keep our actually keep our area of the triangular face because we're going to use that again. Okay, get rid of this part here. Now, what we have here is we have two triangular faces, okay? Because there's going to be another triangular face at the back down here. Okay, so that's going to be your second triangular face is going to be in there. And then you're going to have a rectangular face at the back. So two rectangles, two triangles, sorry, three rectangles and two triangles, okay? So we're going to label them. So there's going to be two A's, which is going to be the area of the triangular face, which is 24 centimeters squared. So we have two triangles, each of 24 centimeters squared. Okay, so that's the two of them done. Now we're going to have face B. Face B is a big rectangle, and it's of length 4 and width and breadth 10. So this one's going to be 40 centimeters squared because length by breadth is 40 centimeters. Okay, so that's B is going to be that much. Now we're going to go on to the base, which is a smaller rectangle of 4 by 6. So then we're going to have the base one, which is going to be 4 by 6 or 6 by 4, which is going to get us 24 centimeters squared because length by breadth is 6 by 4 is 24 centimeters squared. And finally we're going to have the back face, which is we're going to put in black here. So we call this one here C, face C, and now we're on face D. Face D is at the back, and face D is going to be 8 by 4. Okay, so face D is going to be 8 by 4, which is going to give us 32 centimeters squared. Okay, so what's going to happen next is we're going to add them all up together. So we're going to get two 24s for the triangles, a 40 for the red rectangle, a 24 for the base rectangle, and 32 for the rectangle at the back. So we're going to add them all up together. And what we're going to get is 144 centimeters squared, which is exactly what we're looking for, which is perfect. 144 centimeters squared. Okay, so we're correct so far. Now, time to move on to question 2. Okay, so question 2. Taking pi as 3.14, find the area of the sector shown. Area of the sector. Okay, so we just go down to our formulas. Maybe look for the area of the sector formula. Area of sector formula is located here. So we're just going to take this formula and paste it here. Okay, so there's the area of the sector formula. So it's whatever angle, theta is the angle we're looking for. So it's going to be 120 divided by 360, because it's a third of the full circle. Okay, so the full circle will continue around here, and it's basically a third of the full circle. Okay, so and then we're going to multiply it by the area of the circle formula, which is going to be pi. Pi is 3.14, and then the radius squared. The radius is 6, so it's going to be 6 squared. Okay, so it's going to be, just put this directly into your calculator exactly as it looks, and what we're going to get is 37.68 centimeters squared. Okay, now find the area of the section zone. That's what we got. We can check our answer here. 37.68, correct. Okay, now we're on to the next one. Find the area of the given parallelogram, hence find the value of the height h. Okay, so we need to look for the area of parallelogram formula. Okay, so we're going to go down through our formulas again, looking for the area of a parallelogram, and here it is here. So you're just going to use this formula to do this question. Okay, so here it is here. Now, base by height. So we got to look for a base and a height. So what we know is a base could be 8 and the height could be 9. So we can use base by height for 8 by 9. So 8 by 9 gives us 72 centimeters squared. Now, another way of getting this would have been to use 10 and h, okay? Because 10 could be the base here, and h is the height coming from that base. So we could also say that base by height could be 10 by h, and that also has to equal 72 centimeters squared because it's the same, basically the same parallelogram. So 10h equals 72. It's 10 multiplied by h, so when you bring the 10 over, it becomes divided by 10, and that's going to get us 7.2 centimeters. Okay, and 7.2 centimeters it is. Okay, next one. The cuboid can be made from a following piece of card shaped like this. So this cube, when it's folded over, when we fold this over, what we can do there is we can turn it into this cuboid as shown. Okay, so that's what happens when we fold it over. Okay, now find the volume of the cuboid. Okay, now each square is worth 3. So this here has 1, 2, 3, 4 squares. That's going to be 12. This part here is going to be worth 9. This part here is also going to be worth 9. This part here is going to be worth 12. Okay, and this part here is going to be worth 3. So we can see that the narrow side, this is going to be of a height 3. Okay, and then we next need to find the width. Okay, so the width, you can see that it looks narrow, so the width is going to be 9, and the length is going to be 12. So now we can find the volume of the cuboid. So the volume of the cuboid is length by width by height. We're just going to get 12 by 9 by 3, and that should get us 12 by 9 by 3 is 324 centimeters squared, or centimeters cubed. Okay, the total surface area of the cuboid. So to find the surface area of the cuboid, what we need to do is we need to calculate each area of each of the rectangles shown. The first rectangle is 9 by 12, which is going to get us 9 by 12 is 108. So that one there is going to be 108. The next one here is going to be 3 by 12, because it's 3 multiplied by 12. So the first one is going to be 9 by 12, which is 108. The next one here is going to be 3 by 12, which is 36. The next one we could do here would be use 9 here. So we could do once again another 9 by 12, which is 108. Okay, and this one here is the same thing, it's going to be 36. Now the final two cuboids we don't have the answer for would be 9 by 3 and 9 by 3. So 9 multiplied by 3 is 27. So you have 27 and 27. Now we got to add all these up together. So what we need to do is just take away the extra numbers that we don't need. Okay, and so what we'd have here is we just got to add all these numbers together. Okay, so what's going to happen is we're going to get 108, and this for part 2. 108 plus 36 plus 108 plus 36 plus 27 plus 27. And what we get here is 108 plus 36 plus 108 plus 36 plus 27 plus 27. And we're going to get 342 centimeters squared. Okay, so just go and check out both these answers. 324 and 342 correct. We're now on question 3. Question 3 now. Okay, now question 3. Okay, given the following figure consists of a square and a semicircle, taking pi, correct, find the area of the figure and the perimeter of the figure. Okay. Okay, so this one here we need the area of the figure. Okay, so we have two shapes here. We have a semicircle and we have a rectangle. Now, what's going to happen is it's going to be, these lines mean that it's the same length, and it says it's a square. Okay, so the area of the square is going to be 8 by 8. So 8 by 8 is going to get you 64 centimeters squared. Okay, so 8 multiplied by 8 gives you 64 centimeters squared for the area of the square. Okay, next we have to get the area of the semicircle. Now to get the area of a semicircle, what we do is we go back to our sector formula, which is this one here. Now, area of the sector means we have half the circle this time. So what we need to do here, so you can just paste this here. Now, what is the angle that's in a semicircle? Now, the angle here is going to be 180 degrees, okay? So it's going to be 180 degrees, okay? We're just going to give us half a circle. So what we're going to do is we're going to put in 180 divided by 360 multiplied by the area of a circle formula, and we're asked to take pi as 3.14. So 3.14 multiplied by r squared, and r squared. Now the radius of this circle, it's not 8, it's going to be 4, because it's going to be half the diameter of the circle, which is 4. So 4 squared. Now it's important to remember, 180 divided by 360 is actually a half. So you're basically getting half of the area of the circle here, okay? So you can just put all of this into your calculator exactly as it looks, and you can find your answer out now. So it's going to be 3.14 multiplied by 16. So the area of this is going to be 25.12. So 25.12. So now what we've got to do is we've got to add both answers together to find the area of the figure. So 64 plus 25.12. And what we're going to get here is 89.12 centimeters squared. Okay, so we're just going to check that. 89.1 when it's rounded off to one decimal place. Correct to one decimal place, so we just got to make sure we read the question exactly. So it's going to be 89.1 centimeters squared. Okay, so now that we have this question done, we're going to move on to the next part, and this involves finding the perimeter. Okay, so we don't no longer need this formula here. So now we're gone. So find the perimeter of the figure. Now what the perimeter of the figure is looking for how if I do a lap of it, the perimeter means you're running all the way around the object and you're going to come back at the start. Okay, so it's just a lap of the full object. Okay, so what we need to do here is we can start off with that. We know that that's going to be 8 and that's going to be 8. This here is going to be the length of the arc. We're going to call this L. So it's going to be 24 plus L. Now we need a formula to find out what L is, okay? So when you go back to the start, okay, you're going to look for the area of a sector, or the length of a sector, length of an arc. Now here's the length of the arc formula, okay? Now the length of the arc formula. The length of the arc formula is basically using the length or the circumference of the full circle, and then we're going to find out what half that distance is. Okay, so this 2 pi r here, that refers to the area, that refers to the length of the full circle. Okay, and what this part does here is it tells you how much of the circle you're covering. So in this case, we're covering half a circle. Okay, so we're only covering here to here. So therefore the rest of the lines have to disappear. So that means that we're getting half a circle, okay? So we're only going to find out the distance from here to here. So what we're going to do next is we're just going to put this into the formula and see what happens. So it's 180 degrees like last time. So it's 180 divided by 360. And then you're going to multiply that by 2. You're going to multiply that by 3.14. And then this is what L equals. And then you're going to multiply that by the radius, and the radius, as we said before, is 4. Okay, so straight into your calculator. 0.5 multiplied by 2 multiplied by 3.14 multiplied by 4. And what we're going to get here is 12.56. So L equals 12.56. So now we get 24 plus 12.56, and this means our answer is going to be 36.56, and we got to round it off to the nearest decimal, so it's going to be 56 is closer to 60, so it's going to be 36.6 centimeters. Okay, so just check that out. 36.6. Okay, we're on schedule, right? A 1:50 scale model of a yacht is to be built. Right, this is something to do with the question. If the yacht is 25 meters long, how long would the model yacht be? Okay, so 1:50 means that it's 50 times smaller than the original yacht. Okay, so it's 1 to 50. So what we're going to do is we're going to convert 25 meters into centimeters. Okay, and remember 1 meter equals 100 centimeters. So we got to multiply 25 by 100, and we know that 25 meters is therefore equal to 2,500 centimeters. Okay. Now this is the size of the yacht in real life. Okay. So size of yacht, length of yacht. Length of yacht is 2,500 centimeters. Now remember, the model is 50 times smaller, so length of model just divided by 50. And what it's going to be, the length of the model. So it's going to be 2,500 divided by 50. It's going to be 50 centimeters, or half a meter. Depends on what way do you want the answer. Okay, so 50 centimeters or half a meter. So we'll see what way is given. It's given as 50 centimeters. Okay. Next question. A scale drawn is to be made of a car. If the car is 6.25 meters long and the model is 25 centimeters long, what should the scale be? So once again, like last time, get the length of the car in centimeters. So the length of the car is going to be 6.25 multiplied by 100 to change it into centimeters, and that's going to get you 625 centimeters. Okay. Now the length of the model. The length of the model is 25 centimeters. So we have to find out how much bigger the car is than the actual model. So how much times bigger is the car bigger than the model? So the scale factor will be equal to length of model divided by length of car. The scale factor will be length of car divided by length of model. Okay. So we get is 625 divided by 25. So it's going to be 25 times bigger. Okay, so 1 is to 25 ratio. Okay. So it's going to be 1 is to 25. So the real object is 25 times bigger than the model. Okay. So 1 is to 25. Correct. Okay. Next one, part C. Show that prisms A and B have the same volume. Okay. So in prism A, we need to get the area of the face. So the area of the face is 3 by 2, which is 6. So area of prism A equals 6 multiplied by the length, which is, remember, it's area of face multiplied by length, so it's going to be 6 multiplied by 3, which is going to give us 18 centimeters cubed. Okay. Now for B, it's a triangular face. Okay. So the length is going to be for B. The length is going to be 6. So length equals 6, and the area of the face is going to be a half base by height, which is going to be a half. The base is 3, and the height is 2, and this is going to give us 3. So area of prism B is going to be just 3 multiplied by 6 equals 18 centimeters cubed. So they both have the same area. Okay. Now, are the surface areas the same? So next thing we got to do is check out, are the surface areas actually the same as well? So although the areas are the same, we don't know if the surface areas are the same. So what we can say is, we might just use the formula for this one. Okay. So the surface area of a cuboid So the surface area of a rectangular solid. Okay. Now, what we can do is we can get the area of each side. So the area of the first side is going to be 3 by 2. This is 3 by 2, which is 6. Okay, so that means the area of the back face is 6, and the area of the front face is 6. So that means there's two faces that have area 6. Okay, so this is 3 by 2, which is 6. Then we have the side areas, which is also 3 by 2. So that's 3 by 2 for the front and back. So we call that A, and A is 6 centimeters. And there's two of them. Okay, area of B, which is the side, and B is going to be 3 by 2 again, which is also 6. So the area of B is 6. And remember, there's two B's, the side, the right and the left. Now we need to find the top and the bottom. Okay, and the top and the bottom is going to be 3 by 3. It has a square top and square bottom. So C on the bottom here. So the top and the bottom we'll call area C. And area C is going to be, it's going to be an actual square. Okay, so it's going to be 3 by 3, which gets you 9. So C equals 9. Now, the key thing to remember is that there's two A's, two B's, and two C's. So it's going to be 12 plus 12 plus 18. So 18 plus 24. It's going to be 42 centimeters. 42 centimeters squared, right? So that's what the surface area of prism A is. Okay, so 42 centimeters squared for the surface area of A. Now, B is a different story. It's a triangular face. Okay, so there's two triangular faces, the front and the back. Okay, we know that it's 3, and we know the height is 2. So the area of the front is going to be area equals a half base by height, so it's half 3 by 2, and that gets you 3 centimeters squared. Now remember, there's two of them, so we got to change that to 6 centimeters squared. Now, there's two side ones, which we'll call D. Okay, so there's a side face here, and there's a side face behind. Okay, so there's two of them. So the area of these are going to be, they're of length 6 and width 2.5. So the area is going to be 6 multiplied by 2.5. It's going to be 15 centimeters. Alright, so 15 meters squared. Sorry, everything's in meters. So I've been getting my units wrong, which is a problem. Meters squared, meters squared. Okay, so it's 15 meters squared. There's two of them. So that's going to make 30 meters squared. Okay, so once again, so it's going to be 6 plus 30 meters squared. And then the only thing we're forgetting then is the base rectangle. So there's 3 rectangles on this, and then we have the base rectangle, which is the one on the very bottom. Okay, so this rectangle here on the bottom. Okay, and this rectangle here on the bottom, we're going to color in, actually color it in green. Okay, so the green rectangle on the bottom is going to be 3 by 6. It's going to be the biggest rectangle. So it's going to be 3 by 6, and that's going to get us 18 meters squared. And there's only one of them, so it's plus 18. Now we're going to add all three together. 6 plus 30. 30 plus 6 plus 18 is 54 meters squared. So basically the triangle has a bigger surface area. Okay. Prism B represents a large tent with a floor made of canvas. Find the cost of canvas used if each square meter of the canvas costs 24.5 euro. Well, we know the full area is 54, so we multiply 54 by 24.5, and what we get is 1,323 euro. Okay, so let's check out these answers here. Correct, and they're not the same. Okay, next question, which is question 4. The diagram shows a quadrant of a circle of radius 14 centimeters. Taking pi as 22 or 7, find the area of the shaded portion of the figure. Now to get the shaded portion, all what we gotta do is find the area of the triangle, which is this part here, and then from the triangle we need to find the area of the sector, and then we can take the sector away from the triangle. We can take the sector away from the triangle, and therefore we can find out what is the area of the basically the green region here. Okay, so that'd be the extra region here. Okay, so we need to find that out. So what we do is first and foremost find the area of the triangle. So it's going to be 14 by 14, a half base by height, and they're centimeters this time. So area of triangle equals a half base by height, which is a half 14 by 14, which ends up to be 98 meters squared, centimeters squared. Okay. Next we got to find the area of the sector. Okay, and to do this you might want to use your area of the sector formula. Okay, so just get the area of the full circle and divide it by 4. Basically will be the gist of it. Okay, so what we're going to do here, so this is what we're going to do to find this one. Okay, so we're using the formula to the right here, the area of the sector formula. So what we know is that this is a 90-degree angle because it's a quarter. The word quadrant comes from quarter, so it's 90 degrees. Okay, so it's going to be 90 divided by 360. Then you're going to multiply by pi r squared. Pi is going to be 22 over 7 in this question, and r squared is going to be 14 squared. Put all that directly into the calculator. It's basically a quarter of a circle. The 90 over 360 represents the quarter, okay? Okay, it's going to be 154. So equals 154. Okay, so we need to take the sector minus the rectangle. So 154 minus 98, and that's going to give us 154 minus 98, and that's going to give us 56 centimeters squared. Okay, so 56 centimeters squared. Okay, so we just go back here, 56 centimeters squared, no bothers. Okay, next one. The figure shown is made from two identical overlapping rectangles which are 20 centimeters long and 15 centimeters wide. Find the area of the figure. Okay, so what we can say here is from here to here is 20. From here to here is 15. This here is also 15 because the smaller length is 15. Okay, therefore this entire length here is also 20. Okay, therefore it makes this length 5. Okay, this length here is also 5. Okay, so what we can now do is once you know all these figures, okay, what you can next say is this is going to be 5 by 15. Alright, it's area of a rectangle, so 5 multiplied by 15 gives you 75. This one here is also going to be 5 by 15. That's also going to give you 75. And finally this one here is going to be a 15 multiplied by 15, and that's going to give you 225. So add all the answers together, you're going to get 75 plus 75 plus 225, and what we get here is 375 centimeters squared. Okay, so 375 centimeters squared. Okay, next one. Now, we're going to use the area of a sector, I think. What is the length of the minute hand? It covers an area of 88. So basically the minute hand moves, it starts off here at 8 and then it moves up towards in between 10 and 11. It covers a 75-degree angle and it makes a sector shaded in purple, okay? So the area of the sector formula is shown below. So what we need to do is we need to use this, okay? So it's going to be 75 degrees divided by 360. We know that pi is the pi key on the calculator, so we just use the calculator. And we don't know what r squared is, so r squared is unknown to us, okay? So r squared, we don't know what it is, and this all must equal 88 centimeters. Okay, so we're going to put this in our calculator. 75 divided by 360. So this section here can go directly into the calculator and we can put it into decimal form. So what we end up getting is we end up getting here is 0.65, and if we round it up, 0.6545, r squared equals 88. Now we want to get the r squared on its own. So this part here, the 0.6545, is multiply on the left, which means it will be divided on the right. So 88 divided by 0.6545, and what we get here is r squared equals 134.4538. Okay. Next thing we need to do is we need to find out what number multiplies by itself to give you 134.4538. So you just square root it, and what r will equal then is 11.59. 11.595, and this give your answer to two decimal places, so it wants 11.6. okay, 11.60 centimeters. Okay, so let's check this answer out. So 11.6 centimeters is correct. Okay, so next we can move on to question 5 now. Now this question here, right? Find the total length of ribbon used to tie a box illustrated. 15 centimeters extra required to knot and bow. So first thing you need to do is need to pick out one of them you want. We'll start with this one here, right? It goes up 10 centimeters. It goes underneath by 15. On the other side, it goes up another 10. And then it goes across another 15. So we need to calculate how much bow was used in total. So we got 15 plus 10 plus 15 plus 10. And that's going to be 50 centimeters for this bow going in this direction. Okay. Now the next thing we got to do is the next bow going in the other direction here, which is going to be, it's going to cover 20 centimeters on top. It's going to drop down 10. It's going to cover another 20 centimeters underneath, and then it's going to go up another 10. So it's going to be 20 plus 10 plus 20 plus 10. That equals 60 centimeters. Okay. Now add them both together, we get 110 centimeters total, plus the 15 centimeters extra. That's going to give us 125 centimeters. Okay, 125 centimeters. Okay, that's that one correct. Next one, 5b. A map has a scale of 1 to 25,000. That means that in the scale map it's 25,000 times bigger in real life. What's the actual distance of the scale distance 4 centimeters? So 4 centimeters is actually 25,000 times bigger in real life. So multiply 4 by 25,000, and you get, I think it's 100,000 centimeters. Okay. Now we'd like this in meters. So remember, 1 meter equals 100 centimeters. So if we divide by 100, we should get it in meters. So it's going to be equal to 1,000 meters. And 1,000 meters is the same thing as 1 kilometer. Okay, so it depends which way it wants the answer. It wants the answer probably in kilometers. We'll check that out now. Meters or kilometers, it doesn't say, so either one will be useful. So 1 kilometer is what I actually wanted. Okay, next one. We're going backwards. Okay, what's the scale distance if the actual distance is 3.5 kilometers? Okay, so 3.5 kilometers. If you multiply that by 1,000, it's the same thing as 3,500 meters. Okay, and 3,500 meters, you're going to multiply that by 100 to change it into centimeters. So you get 3,500 multiplied by 100, and you get 350,000 centimeters. Now this is the length of the actual distance. Now to get the map length, so the real length is this much, and now we're looking to get the map length. And remember, the map length is 25,000 times smaller, so we got to divide that by 25,000. And when we do that, we get 14. So the answer is going to be 14 centimeters. Okay, and I know that's the right answer. Just seen it there a second ago. Okay, now we're on to 5C. The volume of the prism is 254 centimeters cubed. Find the value K. So I'm going to find the area A first. And the area A, it's a triangular face. So it's going to be a half base by height. So it's going to be equal to half B by H, which is a half 7 times 5. And that should get me 17.5 if I'm correct. 17.5 centimeters squared. The area of the volume of the prism. The volume of prism equals, now K is the length, okay? So usually equals area multiplied by length. In this case, it's going to be 17.5 times K, or 17.5 K, and this answer is going to be equal to 245. So to get K on its own, divide 245 by 17.5. 245 divided by 17.5, and we get is K is 14 centimeters. Okay. And K is 14 centimeters. Okay, next one. A farmer wants to sell his fields. He wants more than 24 euro per square meter. Mr. Dunn offers him a total of 90,000 for the field. Should the farmer accept this offer? Give explanation. Right. So we have to see how much he's offering for how much land. So the first thing we need to do is need to find the area of this field. So what I'm going to do is I'm going to continue down this line here. Okay, and I'm going to make a triangle and a rectangle. Now the rectangle is the easy one to get, the easy marks. It has a length of 56 and a width of 39. So 56 multiplied by 39, that's going to get us it's going to get us 2,194. Now the next one is the triangle, and the triangle we got to figure out the sizes of the triangle. Okay, so the triangle has we can see that's 39 and 23. So 39 plus 23 will give us the height of the triangle. So 39 plus 23 gives you 62. So the triangle is 62 meters tall, and its width, the entire width is meant to be 104. Okay, so we take 56 from 104. because remember 56 of it is included already. So 104 minus 56 gives us 48. So the area of the rectangle has a base of 48 and a height of 62. So the area of the rectangle, the area of the triangle therefore is it's a half base by height, which is a half 48 times 62. Which is 1,488 meters, okay? We're going to add them both together to get the total number, the total area. Plus 2194 gets you 3,682 meters, okay? Now, meters squared, that is, because it's an area. Okay? Now, 3,682 meters squared, Mr. Dunn wants to offer 90,000 for this, okay? So we have to find out how much 1 meter squared costs. So 1 meter squared must equal, bring over to 3,682. It was multiply. Now it's going to be divide because it's over the other side. And what's happening is 90,000 divided by the answer there. And he's going to get 24.44 euro per meter squared. So this is more than he wanted. So he should accept the offer, okay? Because it's a bigger number than he wanted. So let's find out. Yes, he should take the offer, okay? Now, the next shown will follow to make a prism. Describe fully the prism it will make, right? So the prism it will make, okay, we'll have a triangle here at the front, a similarly sized triangle at the back, and what's going to happen is these are going to be joined together to make three rectangular faces, a base and two sides, and two triangular faces at the front and back. Now the triangular faces at the front and back, they're going to be height 1.7 centimeters. Okay, its length here should be 4, and the width at the front will be 2, and the side distance here will also be 2. Okay, so the volume equals the area of the triangle, area multiplied by the length. Okay, so the area of the triangle, if we were to find out the area of the triangle, it's going to be 1.7, a half base by height, 2 is the base, 1.7 is the height. So the area of the triangular face is going to be a half, 2 times 1.7, that's going to be 1.7 meters squared. Okay, so it's going to be 1.7 multiplied by the length, centimeters squared, that is 1.7 multiplied by the length of 4, and that's going to get us 6.8 centimeters squared. Okay, so let's just see if we're right here. 6.8 centimeters squared, and it's a triangular prism, right? Now the reason why it's a triangular prism is it has two triangular faces, so this here is a triangular prism. Now to find the surface area, okay? Now to find the surface area, we're going to use the answer we used before regards the area of the front face. Now the area of the front face is going to be 1.7. So 1.7 here and 1.7 here at the end. Okay, so it's going to be 1.7 plus 1.7. The next thing we got to do is we got to find out the area of the rectangular faces. Okay, so we're going to take the rectangular face on the left. Okay, so the rectangular face on the left and the right, these ones here. Okay, not the base one. Okay, and that's going to be 4 by 2, which is going to be 8 centimeters squared, because a length of 4 and a width of 2. So it's going to be plus 2 eighths, because there's two of these. And then we're going to have the base triangle, which is in green, and this one is also the base triangle is also going to be 4 by 2, which is another 8. So add them all together, and we're going to get 27.4. So the surface area equals 27.4 centimeters squared. Okay. So 27.4 centimeters squared, grand. Now we're on the last question. Now, the large circle has an area of 129 centimeters squared. What is the area of the shaded region? Correct to 1 decimal place. So the area of the big circle, area of a circle is pi r squared, and that equals 129 centimeters. This means that r squared is equal to 129 divided by pi. So r squared, and this is the radius of the big circle, okay? R squared equals 129 divided by pi is 41.062. Therefore the radius must be square root of this, 6.408. That's the radius, okay? That's the radius of the big circle. Now, what we need to find next is the radius of the small circle. So if the radius of the big circle is 6.408, the radius of the small circle has to be half this distance, okay? So, radius of the small circle, therefore, is 3.204. Now, the area of a small circle, so the area of the small circle is pi r squared again, so it's going to be pi multiplied by 3.204 squared. And that's going to get you straight into the calculator. And that's going to get us 32.25. Now each small circle is worth 32.25. That's 32.25. This one here is worth 32.25. Okay, so we're going to multiply that by 2. And you're going to get 64.5. So basically it's the entire area minus 64.5. So to finish off this question, what we need to do now is 129 minus 64.5. And what you get as the answer is 64.5. So, centimeters squared. Right, so 64.5 is the answer to the last question, which is correct. And that ends this video.